Okay, now I know we're starting to glaze over, but oh well, sorry. Gotta get going. Normally I would go into gprof. As I mentioned at the very beginning, this will profile, and it actually is very nice because once you have your code fully profiled, it'll tell you, hey, look, you're spending 97.74% of your code inside a function called func2. When I came in, I tested this to make sure it works before I presented it, and it absolutely does not. So we're not going to be using a profiler for now. I will hopefully be able to return to this later. Instead, we're going to use gnuplot. All right, gnuplot I think is actually pretty simple. If you don't have it installed, apt install gnuplot. Let's go ahead and jump over to a terminal. Gnuplot. Comes up again with its own little terminal. You can type in plot sine of x with line. All right, good. Plot sine of x with line. Hey, look at that. It made a graph, the sine of x. It's amazing. With point, instead, if you don't want to use a line, you can use point, and it'll start putting some points on the graph for you. All right. Whoop-de-doo. What do we got? Oh, okay. Let me quit out of this. Let me go and make a gnuplot directory. All right. And we'll go ahead and plot with point. That prints it out to the screen, but it actually is useful if we can save this as a file. So if you set terminal PostScript color, that says, hey, give us some color. And I think the next one, yeah, that's fine. Next one is the output, so set, is it just output? Output, great. Output, we'll just call it out.postscript. All right, it's good. And then we can type in replot. It says, okay, I did that. Well, what just happened here? Well, let me open up a new terminal tab. This tab is this terminal. This tab over here is the same terminal in the same, or a different terminal in the same location. Hey, out.ps was created, so can I evince it? And look, now I have a PostScript file with it, so I can print it and do whatever I want. Okay, you'll see it's a command line tool to create graphs. Great. You can set the title, set the Y label, set the X label, and you can even convert it from a PostScript to a PDF using PS2PDF. Again, just install it, apt install, PS to PDF, and then that'll work as well. I'll go over there and show you that. Actually, we go back over here, we can set title to first. And what is it? Set X label to X. Oops, X label X, set Y label to Y. And then we'll replot. Sure. PS2 PDF, out.ps. If I do an ls, we now have a PDF. And now I can make a PDF. Look at it. It actually appended it. Look, it has a title of first and Y label. And if I were able to scroll down, we have the X label down here. Okay. It's a tool. It does basic graph generation for you. All right, why am I teaching this thing? Okay, first off, before I go any further, you can save all your plot stuff into a plot file, which is exactly how I use it, because trying to remember all these commands and typing them in is just silly. Simple.plot. We can do set, was it PostScript color? What else we got? Set output to simple.ps. And what else we got? Set Y label to Y. Set X label to X. And then we can go ahead and plot sine of X with line. Okay, why would we do this? Because now we can just gnuplot simple.plot. PostScript, did I set it wrong? Set terminal. Oops. Terminal. So now, PostScript did not set the output. Did not set an output. Set output simple.ps with quotes. So you actually do it right. There's simple.ps. Now we can do ps to pdf simple.ps and then evince it. And there you go. So you can have a plot file for this. All right, why am I going through all this? You can put it in a make file, which we'll show in a moment. This goes along with timings. For your next lab, which we're trying to get to, you need to actually record the timings of different functions. There are numerous approaches to this. This is the standard, or I should say, not the standard, definitely not the standard. This is the beginning, I'm going to say naive, way of doing it, which is going to be perfectly fine for this class. Step 1, record a start time. Step 2, run your code, record an end time, subtract the 2, you're done. There are a ton of issues with this, but we're going to ignore them all. I don't have time to teach all that. Here's the timing code. That looks complicated. Let me show you what it actually is. I'm going to gvim inside of your inside of upstream. I've created inside of class code directory a timing template.cpp, which is this code right here. I highly recommend you use this for your timings, as it will make your life simple or easier. All right, include some stuff. Start main. Clock_t is the directive used to start the clock. Sorry, going fast. We're running out of time. Double time amount is a variable to store your time. For I up to some number plus equal. I is the program size that you wish to run. You start the clock. You run whatever function you want. Keep in mind that I is the size of the input, so you may have to change what I actually is. Capture the clock. Divide it out so it gives it to you in seconds, print it, and then always don't ever forget to flush at the end. Okay. Makes sense what the code's kind of doing overall? Keep in mind that I is incrementing slowly, so for each different size, it's going to run your program for a different size, starting at one, then another, then another, then another. Okay. So let's go back to, we're in gnuplot. We'll go ahead and copy timing template to first timings.cpp. We'll gmin first timings. We need a function to call for I, so we'll have int function1, int I, int sum equals 0. We'll just do a simple for int. We can't have I here, so we're going to change this to n. I is less than n, I plus plus, you again, I plus equals, or I should say sum plus equals I, and then we'll return sum. Hopefully you all know that there's a faster way of doing this, but that's okay, we're going to stick with this. So a function you are to call, I'm going to call it function1 instead. Save that. Let's go ahead and create a makefile. Or I should do first timings.o is based on first timings.cpp. G++, we'll go ahead and put in our C flags, -c first timings.cpp. It's going to be great when I can simplify this for you all. All first timings.o. G++ will do C flags -o. Well, I'm going to call it first timings from first timings.o. All right. Looks good. We still need our C flags. And let's go ahead and do a clean. There it is. Wonder why it's doing that. All right, let's save that. Go back to command line, make, missing operator stuff. Oh, gvim, no. No. It put in spaces. Oh, I put in spaces. Oh, it's still putting in spaces. gvim is betraying me. There it goes. There we are. Make. Perfect. Run first timings. Oh, it sped out a lot. So when I ran it this time, notice that or the first column is the size of I, the second column is the time it took. When he gives you numbers like this, that means your I is probably way too low. So we need to fix that for this problem. Let's go ahead and quit. Look at GVim real quick. We'll go ahead and increase, put some zeros in. Save it. Yeah. And we'll do another make. Wow, still too low.
What if you went up by 1 so much?
Hmm?
You went up by 1 instead?
That's not going to quite do what we want. Let me make sure I'm calling this correctly. Function 1 int I. Here's the other problem. I needs to start at 0. There we go. Okay. All right. Well, that's going to take a while. Let's stop that. Let's
We made it work. And we don't want it anymore.
yeah. Let's not. Yeah, I know. I'm so picky. Oh, hold on.
That was fast.
It's faster. Oh, how many zeros is that? Okay, so we're in the millions. So we're about ready to be in the billions. How high does this thing go? 1, 2, 3. 1, 2, 3. Oh, yeah. Let's take out another 0. And then there we go. Okay, never mind. Yeah, we're going to leave it like that. Okay. So it gave us 2 columns, the size on the left, timing on the right. Why is this useful? Well, first timing's into, I'll call it out.data. We'll go ahead and run it. Now it's going to dump the output to out.data. Why is this useful? Well, while it's running, it looks up something like this. We can then use gnuplot to automatically generate the plot for us. So let's assume we have full listings in some file. So we can do plot, semicolon, semicolon, the file name using 1:2 with line. All right, let's jump over and see what that looks like. Hopefully I'm done running. Good. Let's open up simple.plot. Remember that was our plot file? And I think it was, so we do plot, colon, colon, and then the file which was called, let's see, out.data with line. Okay. Did I do that right? Using 1:2. All right, here we go. Using 1:2 with line. All right, let's see if gnuplot's going to do that. Okay, and we can events out.postscript. That's not it at all. So we call it simple.ps. Simple.ps. There we go. What type of function do you think this is? O of n. You see you can kind of apply a linear function to this. Why is it jumping up and down a lot? You'll find out in computer architecture. But there's a lot of little things happening. I bet you this jump is when I went from this screen over to the other one. So that was overloading the system a little and affecting the performance here. Okay. Do you see how you could do this for a lot of many different algorithms and programs and give you an empirical? Great. You can do this with 2, by the way, and compare them side by side. Plot using 1:2 and then comma your next file using 1:2 with line. So plot 1, 1, and 2 the other. And you really care about the colors, you can change it, whatever. And you can append more and more in this manner. Okay. One thing I wanted to show you is that we did that. Remember, make files are your friend. So we can make a little plot directive. Gnuplot simple.plot. We could do a ps2 pdf of simple.ps and then go ahead and just events it afterwards. So what this does, make plot, it recreates the whole plot and just prints it for us, so now it's just one quick command. And now we don't have to type all those things in again. Isn't that nice? Okay. All right, good. Hopefully you can see from today, you can use analyze algorithms analytically to predict the performance. Profiling code, we can get to find what your bottleneck is. That's going to be incredibly important when you get to your project. Gnuplot timings to see actual performance. Performance analysis could take the whole class time if I want to. I can do a whole class on performance analysis, but we're just going to stick with basics. I do want to alert you to a couple of things that will help you out as you're going through these. You plot the data of two algorithms, but you only see one. Actually, can anyone see the second one? Or take a guess where it is?
You're straight up.
Going straight up. Who saw that? Yeah. So someone's got some good eyes. Check your bounds. What's actually happening here is if you looked really closely, it's doing this, but it's really over the black, so you can't see it. So you may want to check your bounds and maybe adjust them. You can manually adjust them if you want to, but do keep in mind that sometimes when you compare two algorithms, the performance difference is so significant that it's almost impossible to see it with a regular graph. We didn't do a profiler, so skipping that. Okay, there's a lot here, I know. First off, be able to analytically deduce the performance of a code. We'll talk about profiling later. Be able to empirically run programs and understand that there are anomalies that are going to happen, that up and down. Ignore that for now. We'll get to that later in architecture, which hopefully you'll take with me. Any questions on this before I assign the lab? Nope, okay.